Anybody from home, you draw 1 to 6 on the left side, vertical line in the middle. You can pause if you need to. You have 15 game pieces, so you've got 15 squares. Put them anywhere here, anything 1 through 6. Make sure you know what numbers they are. So like I just did 3 of them as an example. All right, so the way this works is, now I've done it before where you guys do your own, it just takes longer and I want to go a little bit quicker today. Every time that I roll a die, you are going to do something. Your goal is to get these over here. If I roll a 1, you get to move 1 over. Now, don't do anything yet. Now, you drew them, so instead of you being like, okay, I've moved 1 over, you're just going to go, I got 1 of them. The other thing is, if I don't have anything to move, so like theoretically here, let's say I roll and I roll a 2. I roll again, I roll 3. I roll again, I roll a 5. I roll again, I roll a 5. I don't have anything to move over, so I'm going to put a tally. So you are either marking out or tallying every single time, but just one of the two. Everybody go with that? So we are going to go until someone has their entire left side X out. Questions? So every single time I roll the die, I'll explain it slow at first and then go quick. All right, so the 2. So everybody should either mark out one of their 2s, just one of them, or if you don't have any 2s, then you put a tally on the right side. A 6. Either mark out a 6 or put a tally. Everybody good now? I'm just going to go pretty quick. 6. 6. 3. 3. Let me get 2 dice and go over to there. 1, 3, 2, 4, 4, 5, 6. The way I roll, do stuff in your class is so weird. Like, what do they just go like 1 through 6 straight up? 3, 5, 4, 4, 4, 4. Okay. Are you the only one on this one? Let's go until one more person does them all. But you can yell at me and stop. 6, 4, 4, 2, 2. Alright. So let's look at what we've done so far. What did you notice about? Okay, people that won. What did yours look like? You went first. What did yours look like?
I have at least 1 in every single number.
Have at least 1 in every single number. Who else ended up? What did you have?
I had at least 2 in most of the numbers and 1 from the 1.
2 in most and 1 in some.
I had like mostly in 4.
Mostly in 4. So, if you had to describe your distribution in 1 word, what shape do you think yours would best be? Unimodal?
Yeah, unimodal right skewed.
Unimodal right skewed, unimodal. How many people did something that's like definitely skewed? Or definitely not what they said? How close did you get to winning? 1 away, not close. Somebody else that wasn't anywhere close to winning. Nobody else was nowhere close to winning. What did you have? A bunch of what?
6 5s.
You had a whole bunch of 5s?
Yeah.
Alright, so I had a whole bunch of 5s. What about you?
I put 15 and 5.
Put 15 and 5, you probably nowhere close to winning, right?
I had a whole bunch of 5s.
Had a whole bunch of 5s. Okay, so if we played this game again, what do you think your best bet would be?
Full on four.
The way I rolled 4. Was ours a really big sample? No, was it a tiny sample? No, so we kind of started to see a little bit of stuff. But what do I know about rolling a die? But all equally likely, so my best guess here would be to equally space them out. Now, I purposely gave you 15, so can I do equally with 15? So there's got to be a little bit of variety there. Alright, now we're going to do a different one. Actually, let's go ahead and write this. You can do it underneath, it's fine. So, when I'm rolling a die, let's write out our probability table. Probability distribution table. So, I can call it x and p of x. So, what are my x's going to be? In general, always, what goes on top is your what's. Your sample space or your outcome, same thing. So what are my different outcomes for this one? 1 through 6. What's my probability for each one of these? So if I make a graph of this, what's going to go on the bottom? 1 through 6. But I always have to have a label, so I can just call it X because those are my outcomes. And what do I know about what's this going to be? And what do I need to write there?
1/6.
Just 1/6 because they're all going to be 1/6. I don't need like a beautiful detailed graph here, just better than mine. So the shape of this graph is definitely what? Uniform. Is it symmetrical?
Yeah.
Yes. Where's the center of that graph?
3.5.
So it is symmetrical, so we can find mean exactly without having to do anything. Mean is exactly 3.5. We're going to come back to that part of it a little bit more. What do we usually find with with mean, standard deviation? So if this is our mean, what's your guess on about what standard deviation is going to be?
About
1 something, right? 1.25. If I said 3, would that make sense? So if y'all did on here, if I said 2, yeah, maybe. So somewhere between 1 and 2, 1.25, something like that. We're going to come back to that part of it later. So let's just flip it on the back since I wrote that. So flip it on the back now and write 2 through 12 instead. So same idea, but 2 through 12 now. With this one, why do you think, with me not telling you anything, why do you think that I did 2 through 12?
So you have 2 dollars.
That's 2 dice. Well, what can I not get?
1.
1. We're rolling 2. I can't get 0 on one of them. This time you're going to have 18 markers. So you've got 18 markers. Put them anywhere between 2 and 12. And I was having a conversation about this with someone in my 4th period yesterday. They said that things are kind of finally starting to make sense or piece together in this class. It's almost like me trying to talk to you in Spanish and have a conversation, but you don't know any Spanish yet. So all I've done is taught you a little bit of Spanish, but now we can finally start talking about Spanish. So I've taught you the pieces. Now you know enough for us to even be able to have a conversation. Alright, so this time it is going to be for the sum of 2 dice rolled. So everybody's got 18 markers placed anywhere between 2 and 12, correct? Alright, so I'll call out both and the sum because I know everybody's not going to see. I'll go as quick as I can, but 2 and a 5, we got 7. 4 and a 2, we got 6. 6. 7. Like my legs are gonna be tired tomorrow. 9. 10. 8. 6. 9. 7. 7. 2. 3. 7. 9. 7. 5. 11. 4. 7. 6. 9. 6. 11. 3. 7. Alright, so we're gonna have a conversation now and then I'll keep going. What do you have a lot of tallies for? Anything else other than 7s? So where do you have a lot of tallies? Where do you not have a lot of tallies? Outside. 6. 3. 4. 8. 6. 8. 10. 10. 3. 10. 7. Do I have anybody close? I need 2 12. Some 12, some 4.
Or all of them are
8. 5.
I got it.
Somebody got it? Alright, so what did your, who said that I got it? What did your distribution look like?
That was like 4 through 11. I didn't put any on 2.
Didn't put any on 2 or 12. Did you have more in some places than others?
Yeah, 7 through 10. I put 3 more.
7 through 10, you had 3. What'd you have?
I did like a bell curve with the most at 7 and then fewer as it got towards the edges.
So, anybody who got close, did yours look something like what both of them just explained?
Yes.
Is there anybody who didn't get anywhere close? Did anybody have something that didn't look anything bell-shaped at all? So,
But I only got 2 away.
so you only got 2 away because did you have a whole lot of each?
I had 1 in all of them, and then 7 through 12 I had 2.
Did anybody have a whole bunch in one number? So what I always do is I usually play this twice. So I have people play the first time and then they get mad because I do what so much? 7. So then get mad and put them all in 7. Well, are they going to win that way either? No. So not all going to be 7. It just hurts a lot. So what's the best way to do this? Just like you said, bell curve centered at 7. So let's talk about why this is the case. So how many different things did I actually do? 2. So it's like I did this one, then I did this one. So if we're doing like a tree diagram, how many levels would it have? 2. What's my first level? Rolling my first die. What is my level 2? My second die. Which means I have how many different options? 36. Because 6 here, 36. What I could write probabilities on this. What's the probability that this one is a 1? What's the probability that this one is a 1? All of them end up being 1 out of 6. I could write this out a lot longer. We're not really just concerned with these, though. We're concerned with our answer, and our answer is what? So the 2 added together. So this first path is a sum of what? My second path, the way I have it drawn is 4, 5, 6. What's this one? What's this one? And I could keep going, right? Everybody's good with that? What is the probability of me getting this first path? Because how many of these did I end up having? 36. They're all equally likely. So probably my first path is 1 out of 36. Probably my second path is 1 out of 36, and so forth. Does that mean my probability of the sum of 3 is 1 out of 36? Why? Because there are multiple occurrences here. So how else can I get 1 out of 36 looking at this graph? Other than knowing that there are 36 options. Multiply, I went through here, and I went through here. So, or mathematically means to do what? Add, and mathematically is going to mean to what? Multiply. So, what is, if I had to write, what does that path represent? What is that path?
Roll the 1 and roll 4.
Roll a 1 where? On the first roll.
And roll 4.
And what goes here? I better go with that. What does that part represent?
Roll 1 on the first.
Did I roll a 1 on the first? What's that part represent? So if it's just probability of rolling a 4 on the second, that's not right because it's also over here. So this is the probability that I roll a 4 on the second. What?
After rolling 1.
Everybody understand that? Everybody good with where I am there? Alright, so I'm going to come back to this concept. If I were to write this out, so let's say I'm only going to look at it with one variable. So here's my first variable, roll 1. What are my possible if I know that I threw a die down and it was 1, what's the lowest my possible sum can be? 2. What's the highest my possible sum can be? When I go to, I know the first line is a 2. What's the lowest my sum can be now? Because if it's a 1, and then this will go up 2. We go with that. So this is all of the different 36 scenarios. How many of them have a sum of 1? Or have a sum of 2? How many of them have a sum of 12? How many options have a sum of 3? How many options have a sum of 11? And you see how I keep going. This is the same thing as showing it this way, just if somebody visually likes to see it this way better. Here is my only option from rolling a sum of 1. This is my only option from rolling a sum of 12. These two are my only 2 options of rolling a sum of, sum of 2. Sum of 3, and I can keep going in from there, right? Alright, so let's write this out. We're actually just concerned with what the sum is. So instead of x, I'm going to write this as sum. So what are our possible options for our sum when we roll 2 dice? 2 through 12. So based off of what we were just writing, what is the probability that my sum that I get a sum of 2? 1 out of 36. I'll give you all a chance to get caught up writing. What is my probability of getting a sum of 12? So what am I going to do as I move in?
Goes by doubles.
Now this one goes to 2 out of 36, but then what does it do from there?
Increases to another 1 out of 36.
So that would be 3. So then it goes 3 out of 36. Then 4 out of 36. So where would this one peak? At what sum? At what sum? 7 with a probability of 6 out of 36. So let's draw that one. What's going to go on the bottom? What's my label for the bottom? What's my label for my y-axis? And then what's going to be on the x-axis? And why do I choose to leave gaps in mine? Because they're what? They're completely different values. It's not like you're going from 3 to 4. It's either 3 or it is 4. My spacing's not going to be great, but yeah. I can't flip with this. My spacing's probably gonna be off because I did that, but you'll get the picture here. So what is our mean here? Mean is 7. Symmetrical again, so it's easy to tell where the mean is. What would you guess the standard deviation is going to be for this one? Somewhere around 2 or 3. And now, is that like a definite, like, I know it's going to be this? No, but I mean, the farthest it can go is here. Most of them are here, so
Yeah.
pull it back a little bit. Just, you don't have to take that part right now. So we've got bell shape here. Now, a lot of games use 2 dice. And the concept behind it is this. And most people do not know that, or do not think that, or do not understand that. Like craps, the whole game of craps is based off of that. And I bet most people playing have no idea. Let's do it here right now. Conditional probability. Write that one. So, you can go to your friend's house. You want to go to your friend's house. And your mom says you can only go if you clean your room. So you can only go to your friend's house under the condition that you clean your room. That's what conditional probability is. So it is the probability that one event happens given that another event is already known to have happened. When did we talk about that today?
The dice, the double dice.
And what part of it?
Like
The second.
The second thing. So when I only highlighted the second part, I knew it was already, the first row was already a 1. Now it's probably the second one's a 4. We also dealt with this in chapter 1 because we dealt with conditional versus what? Marginal. So marginal was only using stuff in the margins. Conditional was given the condition of I'm in this column or this row. We actually did conditional probability already. So this is written as a vertical line. This vertical line means the word given. So this is read as probability of B
Given that.
given A. One thing that drives me crazy is about 4 days from now, and somebody goes, "I think you have a typo. You have a line on my paper." You don't even know that that's a thing by now. That we've got bigger issues than you thinking that's a typo. So that vertical line means the word given, which is a conditional. So you don't need to go back and write this, but now I could write this one as, instead of the word after, it would just have this in between. So this is the probability that I roll a 4 on the second die, given that I rolled a 1 on the first die. With this scenario, what is the probability of, in general, probability of rolling a 4? Don't look at this. What's the probability of rolling a 4? Alright. So, given that my first roll is a 1, so given that I knew I went down this branch, now what's the probability that my second one is a 4? So what happened there? Nothing. Is that always going to happen? No. So let's look at a different example first. I want you to draw this one out. We're going to write down all those options. I said example from chapter 1, which means other than this one, at chapter 1, we've cut. This comes from chapter 1, not the exact answer, but it's a concept that we talked about most of this with chapter 1. And we did conditional and marginal. You don't need to write that it comes from chapter 1. And really, you should be able to answer all of these already. We're going to do it together. For right now, I'm not, well, we can go over this. What is the probability that it's a boy?
14.
14 out of 34. Which reduces to what? Let's do it as a decimal, because we haven't talked about decimals in a long time. I don't care if you use your phone or whatever. Just do 3 decimals. So it's 14 out of 34 to 3 decimals.
402.
402.
412.
From the chart, fraction-wise, what is probability of a sophomore? Which is what?
324.
0.324. So all of this problem, I'm only dealing with 2 events. I'm dealing with boy. I'm dealing with sophomore. What is the probability that it is a boy? Actually, let's skip around. Let's go from the bottom. What's the probability it's a boy and a sophomore?
2
2 out of 34, which gives me
0.059.
Alright, so now let's go back up here with this given, this conditional. I read this as probability of what?
Boy given sophomore.
So the given part is all I'm looking at. So given that I'm in that category, now what's probability that's a boy?
2 out of
Which gives me this problem right here, probability of boy given sophomore, most relates to which other one that's here? Maybe this one, maybe what else? I'm finding the probability of what? Very, very generally, I find the probability of a what? I only want the probability of a boy. I just have a condition there. So I can kind of relate it to this, right? So my probability of a boy in general was 0.412. If I'm only looking sophomores, is that probability the same? That changed. Everybody good with that?
Did you say that again?
Yeah, I'm going to bring it back with this one. My probability of rolling a 4 was 1 out of 6. If I knew that I had already rolled a 1, did that probability change? No. But here, my probability of being a boy was 0.412. If I knew that I was only dealing with sophomores, did that probability change?
Yes.
Yes. So this scenario is different than the other one. And then how do I find probability of boy or sophomore?
Probability of sophomore plus probability 1 minus 5 like sophomore.
So probability of boy was 14 out of 34. Should give myself more room. Probability of sophomore was 11 out of 34. Minus my and, which is 2 out of 34. So the fraction that gave me,
23 out of 34.
which is a decimal, is about
0.6 out of 6.
So we'll bring in some not controversial, some outside exterior stuff that's going on. Let's say somebody comes up to me and says, "Hey, I got a really fun thing. Let's go wreck the bathroom." And I'm like, "No, dude, I don't want to do that." And they're like, "No, but it's really cool. Everybody else is doing it." And I still say, "No, dude, that's really stupid. I'm still not going to do it." Am I an independent person or a dependent person? I am independent. Because this external thing happened, everybody's doing it, it's going to be really fun. But what did I do? What did I do? What did this one do? I didn't change. I don't care what your external thing is that's going on. I didn't change. So these two events would be independent. These two events would not be independent. And saying dependent is fine, but usually for some reason this is going to say independent or not independent. So boy and sophomore are not independent. I'm going to write it on the next slide. I just don't have enough room. So I don't care, I'm right with the example. Boy and sophomore are not independent. So I was checking the probability of what in both scenarios? In this case, probability boy. So I was comparing probability boy versus probability of boy what?
Given there's, in something.
And I found that this one was 0.412. I don't remember the number.
Yeah.
And this one was point. And so I knew that those two what? What can I write right here? And that is your whole justification for this. Anytime I ask you if they're independent or not independent. Yes, no. The big thing is, these two things were the same. The thing I'm looking for is still the thing I'm looking for, but now it's just under a condition. I could have done this one the exact same way and did probability of sophomore. I would be comparing probability of sophomore versus what? Given it's a boy. So it didn't matter which one I started with, but I'm comparing, if I start with boy, I'm comparing it to boy, just under the condition of the second thing. If I start with sophomore, I'd still be comparing it to probability of sophomore, just given the condition of a boy. So independent for A and B are independent if probability of A, what?
Does not equal.
Because I'm independent, that's why I always remember. I'm independent because I don't change. So probability of A would equal because I'm starting with myself. I still want to find the probability myself, just given an external condition. And this is a major concept, but this is not something that takes 4 paragraphs to explain. This is literally all you would write as your explanation. They are not, because those do not equal. So our last thing, probability of A and B. We've done this, we've talked about this, but we've actually kind of skipped this without realizing it. How did I find probability of rolling a 1 on the first die and a 4 on the second die? I multiplied. But what were these two events? The word we just went over. What did I know about event? They were what? Independent. So they're independent. All I did was multiply. So a couple days ago when I said, what's the probability of flipping a coin 3 times and getting all 3 tails? Every coin flip is what? Independent. Which means to find that answer, all I have to do was half times half times half. So let's write what we just said. If they're independent, probability of A and B equals probability of A times probability of B. Now, what you don't realize is you've actually already told me this answer by walking through the die example, rolling dice example, because you told it to me in pieces. We just haven't said it all together yet. So we're still going to be finding probability of A and B. So I know I'm using a dependent or an independent example to say this. This path is probably a roll of 1 on the first and a roll of the 4 on the second. Yes? But you told me this part is what? This section is what? Words. This part you told me is probably a what?
On the first.
What is this?
Rolling 4 after rolling.
Rolling a 4 on the second. What?
After rolling 1.
So what can I write here?
Given that you roll 1.
So really, when we do this, it's probably the first thing times probably the second thing given the first one already happened. So everything we do, we can only think about one thing at a time. Like even when I roll the dice, this is the reason I do it, but I always roll one at a time. Like that's the way you have to think about it. You can't be like, I rolled 2 dice, what were they? You have to think about them one at a time. So the first thing is, probably the first thing happens. We already said mathematically, anytime you see and, you know you have to what? Multiply. Probably the second thing given that the first thing just happened. Now, going a little full circle here. Don't mark on this like I'm getting ready to mark on this. The only part of this equation that changed is what?
The second.
So I've got something with probability B, and sometimes I call it instead probability B given A. So if they are independent, why can I only write this?
Probability of B given A, there's equal to the probability of B.
Because probability of B given A is equal to probability of B. This equals that when they're independent. So this is actually the only equation. It's just that if they're independent, I can switch that. Okay, it doesn't change. Probably the first thing happens, probably the second thing happens, given that the first one just happened. But if they're independent, it doesn't matter what happened first.
Oh.
So it would have actually
It
been
would
written
be
the
the
same.
same. Okay.
Questions right now. And I threw a lot at you today on purpose. But I think y'all did really well with it.